So let's go ahead and start talking about systems of linear inequalities. And this is going to be slightly a review because we've done this before on mathletics. So now it's just kind of doing it on pencil and paper, which hopefully you did when you did the mathletics because you like to show your work. Ooh, I know all of you like to show your work. So they're going to give you, well, hopefully you start off on some graph paper, and they're going to give you two inequalities. So we remember kind of working with those inequalities. We might have something like that. And we also might have something y less than or equal to x plus 3. And so let's say I start by graphing just one of the two. Okay? So the x plus 3 one's pretty easy to graph because I just start up 3 on the y-intercept, so that's here, and I go up 1 over 1, up 1 over 1, up 1 over 1, until I have a line, and I see that it's greater than or equal to, which means it is a solid line. Excuse me. So I'm going to draw my line through the points as best as possible. And then I pick a point on either side of the line to help me with my shading. So let's say I pick 0, 0, because that's a pretty easy one to pick. And I say is 0 less than or equal to 0 plus 3? Well, 0 plus 3 is 3, and 0 is less than 3. So I know to shade this side of the line. Now we kind of remember doing that. So that's one of the inequalities that the book gave me, or the problem or whatever. The other one was this top one, negative 2x plus 1. So I start up at 1 on my y-axis, because that's my y-intercept, and that slope is negative 2 over 1. So I'm going to go down 1, 2 over 1, down 1, 2 over 1, down 1, 2 over 1. I see that it's not a solid line, it's a dashed line. So I'm going to draw in my dashed line. I know it's beautiful and straight. And then again, I pick a point on either side of the line to see if it's true. I'm going to go ahead and pick 1, 1, which was over here. So let's see if that's true. So it says 1 is greater than negative 2 times 1 plus 1. Negative 2 times 1 is negative 2. Negative 2 plus 1 is negative 1. 1 is greater than negative 1, so that side of the line is where I shade. So I take my second highlighter, and I shade that side of the line. And ideally, they make some sort of new color. I know blue and green don't actually make that new of a color, but I'm looking for the region in which both are shaded. So that would be this region here. Probably should have done blue and pink so it makes purple. Oh well. So this region in quadrants 1 and 4 is my answer. Just use a third color, it's fine. You really only need 2 colors, but I'm just trying to show that this is where both are shaded, so that's where all my answers lie. Okay, and you may, again, remember this from doing mathletics with the inequalities last chapter. It kind of touches with the inequalities we worked on in chapter 5, but also with systems of equations, which we are doing now. Okay, so go ahead and try this next one on your own. And since it's a review, we'll call it done after that. Okay, so my system is going to be x plus y greater than 2 and negative 4x plus 2y less than 8. First of all, you really do need to put these in y equals mx plus b form. So, for instance, this first one, you'll need to say y is greater than negative x plus 2. This one, we would solve 2y is less than 4x plus 8, and then I would divide every part by 2 till I got y less than 2x plus 4. So then these are the equations I'm going to graph. And it just, going from standard form into the slope-intercept form just makes it easier to graph when I need to do that. Okay? So go ahead and graph it and start shading it in. So this line is the y is greater than x, negative x plus 2. And I'm going to shade this part of the line. And this line in orange is the y is less than 2x plus 4, and I shade below the line. So you can see the part that got double shaded lies in quadrant 1, this little tiny pocket of 2, and then a little bit down in 4. Thanks for watching.